This is the 2016 NAPLAN non-calculator paper. Tim wants to buy some clothes, and the table below shows the prices of the items he wants to buy. We can see all these items here. And Tim estimates the cost of the clothes within a range. Which of these gives the correct range for the cost of clothes? Now we can approximate the polo shirt to about 100, the blue jeans 120. Now, look, the polo shirt's been estimated up to 100. The blue jeans, 120 is almost, it's only 5 cents off. The socks, you can estimate it down to $10, and we can estimate the runners down to $140. So these two have been estimated up a little bit, and these two have been estimated down. So if we look at those values, 100 plus 120 plus 10 plus 140, to add those up, you can add up all the hundreds together, or you can add them up one at a time. So we've got 100 plus 120 is 220, plus 10 is 230, plus 140 is about $370. Or you could, to add those up, you could also do just the hundreds first. So you've got 100 here plus 100 for the next one, just adding up the hundreds, plus 100, and then you can add up all of the tens. So we've got 100, 100, 100, then you can add the 20, the 10, and the 40. So that's another way you can add it up without using a calculator, okay? So, and that would be 100, 100, and 100 is 300, and then we've got 370. So just a few different ways that you can add without a calculator. So 370, and so the estimate is between 350 and 380. Now, Jane and David had identical chocolate bars. David ate 7/8 of his chocolate bar, and Jane ate more of her chocolate than David. So what fraction of her chocolate could Jane have eaten? Now, if Jane ate more chocolate than David, then Jane needs to have eaten more than 7/8. Now, 6/7 is smaller than 7/8, so it can't be that answer. And 6/7, as I was saying, is smaller than 7/8 because it's like you've cut something up into 7 pieces and you're taking 6 of them. So those 7 pieces will be larger than if you cut something up into 8 pieces. So I know we're just 1 piece off the 7, but that 1 piece off the 7 will be larger. So 7/8 is bigger than 6/7. So that is not the answer, the first one. Now, let's compare, see 8/9 and 8/10. 8, if something is cut up into 10 pieces, 8 out of 10 pieces is smaller, will be a smaller amount than if something is cut up into 9 pieces. 8 out of the 9 pieces will be bigger than 8 out of the 10 pieces. So we know that 8/10 is greater than 8/9 is greater than 8/10. So we're going to cross out the 8/10 one. I know that we're trying to compare it to the 7/8, but 8/9 is bigger than 8/10. So we're going to take 8/10 out. We're going to take 6/7 out. Now we need to look at 7/9 and 8/9. Now comparing these two, if we cut something up into 9 pieces, 8/9 will be bigger than 7/9. So what we've got is that 8/9 appears to be the biggest fraction out of all of these fractions. So what we just need to make sure is that 8/9 to see that it is larger than 7/8. We just need to make sure that one of these is bigger than 7/8. So we know that 8/9 is the largest. Let's just compare 7/8 and 8/9. Now, to be able to compare them, we need to have the same denominator. Denominator of 8 and 7, of 8 and 9 is 72. So if we make the denominator 72 for each of those. So how do we go from 8 to 72? Now 8 times 9 is 72. So 7 times 9 is 63. 7/8 into a fraction out of with a denominator of 72. Multiplying numerator and denominator both by 9, we get 63 over 72. And to go from 9 to 72, 9 times 8 is 72. So 8 times 8 is 64, and therefore we can see that 8/9 is greater than 7/8. Okay, and so therefore Jane could have eaten 8/9 of the chocolate bar. Okay. Question 21. Monty and Tara buy pencils for school, and Tara buys 2 times the number of pencils that Monty buys, plus an additional 4 pencils. So we want 2 times the number of pencils that Monty buys, plus 4 more. Now, if M is the number of pencils that Monty buys, it would have to be 2 times M, and then we add 4. So it looks like this first expression is correct. 2 times M. Remember also with order of operations, you always multiply first, and then we add 4. So this one's incorrect because that's 4 times the number of pencils that Monty buys. This one is incorrect because this is the number of pencils that Monty buys divided by 2. And this one is incorrect because it's the number of pencils that Monty buys divided by 4. So therefore the first answer is the correct one. Okay, now for question 22, we have to select the correct statement about this triangle ABC, whether it's obtuse, angled, equilateral, isosceles or scaling. Now, before we can do anything, we know that the angle sum of a triangle is 180 degrees. So angle here at B, so we've got angle B, that would be 180, take away 90, take away 45, which is 45 degrees. So if it's 45 degrees, so if that angle there is 45 degrees, it means that we have an isosceles triangle because we have 2 angles that are equal. Remembering if those 2 angles are equal, then these 2 sides are also equal. Okay, but we know that 2 angles are equal, so it's an isosceles triangle. So therefore triangle ABC is an isosceles triangle. These triangles have 2 equal angles. Amber is keeping silkworms and she records the number of leaves that they have eaten every 5 days. So after 5 days, they have eaten 5 leaves, and after 10 days, which is another 5 days on top of that, they have eaten 15 leaves. And after 15 days, so notice the days are going up by 5s, but the numbers at the bottom, they're going up as well, but they're going up differently. Now, when numbers go up, you can either add from the previous number, or you can multiply. So let's say we say 5 plus what gives 15, that's 5 plus 10 is 15, but 15 plus 10 does not give 45. So this is not a pattern where we are adding to get from one number to the next on this bottom row here. So we try multiplying next. Now, we know that to go from 5 to 15, so how do we go from 5 to 15? We know that 5 times 3 is 15. I'll just fix that up. Okay, so 5 times 3 is 15. Let's see if that keeps working for the next one. Now, 15 times 3 is also 45. So 5 times 3 is 15. 15 times 3 is 45 because we're adding 15 to itself 3 times. So 15 plus 15 is 30 and another 15 is 45. So it appears that times 3 works. And let's try 45 times 3. 5 times 3. You could do 40 times 3. So that's... or you can do 45 plus 45 plus another 45. Now 45 and 45 is, so you can, what you can do is add up the 40s. We've got 40, 80, 120, plus add up the units columns, 5, 10, 15. That's probably the easiest way to do it, which is 135. Now that does work. 45 times 3 is 135. So that means that we need to do 135 times 3. 5 days is 135 times 3. Now to do that, you can do 100 times 3 is 300, 30 times 3 is 90, and 5 times 3 is 15. Now if you can't see that, it really is like doing 135 plus 135 plus 135, which is adding your hundreds together. That's 100 times 3 is 300. Then add your tens columns together. 30 times 3 is 90, and 5 times 3 is 15. So adding up your 300, so now what we do, we add up 300, the 90, and the 15, and that gives us 405. Okay, so therefore if the pattern continues, the the number of silkworms after 25 days will be 405. Okay. Question 24. Hannah flipped a fair coin 60 times and she recorded her results in the table. So when you actually flip a coin, we know we do expect half of the results to be heads and half to be tails, but that doesn't always happen when you flip your coin. So the expected number of heads will be a half of the 60, which is 30. But the actual number of heads that we got was 24. And the question asks for the difference between the expected number of heads and the actual number of heads. Now, difference means to subtract. So it's 30, take away 24, which is 6. And so the answer there is 6. 25, it says Glenn has 6 cups of sugar and a biscuit recipe uses 3/4 of a cup of sugar for each batch. And what is the greatest number of batches that Glenn can make? So we want to see how many 3/4 goes into 6. Now when you want to see something like that, you would divide. So this is one method of doing this. So we would do 6 divided by 3/4. How many 3/4 goes into 6? Now, remembering when you divide by a fraction, you multiply by the reciprocal or the flipped version of the fraction. So 6 divided by 3/4 is the same as 6 times 4/3. Now, when you multiply a whole number by a fraction, it's best to write the whole number as a fraction. So it's 6/1 times 4/3. We then multiply numerators and multiply denominators. So 6 times 4 is 24, and 1 times 3 is 3, and 24 divided by 3 is 8. Now, if you cannot remember, like if you do not think about dividing fractions, the other way is to use a problem-solving approach. So we know that one batch uses 3/4 of a cup of sugar. So let's see what 2 batches would use. So 3/4 plus 3/4. Now you can do this by drawing, I suppose. All right. Say I've got a hole here. Let's say we use 3/4 of a cup. So I've got 1, 2, 3 sections, and another 3/4 would be 1, 2, 3. So I would basically have 1.5 if I did 2 batches, if I used 2 batches, or if I made 2 batches. Okay. So 2 batches is 1.5 cups. Now we can just keep doubling, because we know that we've got 6 cups of sugar, so let's just work up to 6 cups. So if 2 batches is 1.5 cups, so what I did with the first one is I multiplied by 2, okay? I doubled. I said if one batch uses 3/4 of a cup, then 2 batches will use 1.5 cups. So I'm going to double again. So if 1.5 cups for 2 batches, then 4 batches will use 3 cups, because 1.5 times 2, or 1.5 plus 1.5 is 3. So I need 6 cups, so I'm going to times by 2 again. Okay, so timesing by 2 one more time. And so 6 cups, so 3 times 2 is 6, and 4 times 2 is 8 batches. So therefore 8 batches. I can make 8 batches. We'll use 6 cups. Showing this first multiplication, 3/4 plus 3/4. So here I've got 3/4, and if I add 3/4 again, we want to add another 3/4. So we're going to add this now, the 3/4. So I'll put a quarter in there and the other half there. So I can see 3/4 plus 3/4 is 1.5, and that's just showing that first step. And then from there, of course, 1.5, doubling that, 1.5 times 2, so we'll have another full circle, and another half circle gives us three circles.